Good afternoon, everyone. Welcome back to Natural Language Processing course. And today we will learn on chapter 12, Sentimental Analysis using Text Loop module. And this is the outline in this lecture. We will mainly see on the introduction to the Text Loop module, what we can do with Text Loop. And next we will see how we can perform the sentiment analysis using Text Loop module. So now we will come to see the first part. What is text loops? It is basically a Python library which is used to process textual data, and it is built on top of NLTK. So there are many improved features. It is implemented in text loop. So with text loop, it provides the API for many command NLP tasks such as tokenization, post-touching, noun phrase extractions, and also includes the language translation, which is powered by Google API. And this is the documentation to the text loop on its official website. So these give you an overall features which can be used to perform using the text loop module. We can perform noun phrase extractions, post-touching, and of course we can also do the sentiment analysis. And there are many other features including n-grams parsing as well as the spelling correction. So to be able to use the text loop module, we need to install some required library. So to install, we can use these commands: pip3 install using text blobs, and we also need to require to download some Copera which can be used in text blob. And before we can use text loop module, many other available functions, we need to create a text loop object. So how to do this? We need to import a text loop module from the library. And next we can, using the text loop functions, to create a text loop object. So this function actually accepts a string as a parameter. So once you create this object actually can be treated as a string like in Python. And from that object, we can access to some parameter, some functions that are available to perform NLP tasks. So from these example source codes, if we print the object's text loop here, it is just actually a textual strings. So before we can access to the other function like noun phrase, post-touching, language detections, we need to create this object first. So next slide we will see on how we can perform some basic functions using text loop module. So when we work on the part of speech touching, we can access to the part of speech for each word in the sentence. So this can be done using the touch property. We can access these via the text loop object. So take a look on this example. We create a text loop object, and next we can access to these post-touching using this command. So as the result from running this sample program, we obtain the list of words together with its part of speech from the given sentence. And when we want to perform tokenization either on the word and sentence tokenization, we can use the property words and sentences here. So to do this, we do the same, that we need to create a text loop object. And next we can access to these properties to find the word and sentence tokenizations. So as the result from this program, we obtain the list of words from the sentence as well as the list of sentence obtaining from the input text. So as we see in this part, this is obtained using these functions, text loop objects.word, and we have the list of sentence which is obtained by the object.sentences property. And in addition to these basic operation, we can also do some other features using this text group. This we call singularization and pluralization, where we can, given a particular word, we can find its singular or plural form. So how we can do this? We create a text loop object first, and next we can access to all available words using this command, as we have seen on the previous example. And if we want to find the singular or plural of a particular word, we need to access to the word from this word list. So suppose that I find the fourth words in the sentence, because the index is count from 0. So 0, 1, 2, 3 here. So the verb is goes. So you can find the singular form of these words. So we obtain this output, which is the verb go. And we can also access to the information from the last index using this number -1. That means it from the last word here, it counts from -1. So this word is school. We want to find the plural form of this word. So the word school, we have schools here. It is a plural form of this word. And instead of accessing to the singular or plural form of each word, we can apply this function, either singularize or pluralize function, to the whole word list using this command. So this access to the word, and next you can directly find the function pluralize to find all possible words in the given text and convert it into the plural form. So we have this input, cat, dog, and person separated by a space. So after running this command, you obtain the plural form for each of these words. And in addition to the singularization and pluralization, we can also find the word correction or word checking. We can spell check for the given word. Suppose that we have this sentence. It has good spelling, so there are some common errors. There are 3 errors here. Has, spell, good, and spell. So they actually is not in the correct forms. To correct this given sentence, we can find it using the correct function, which once we create the text loop object, we can access to these functions s.correct here. So as the result, we obtain this sentence. It is in the correct form. He has good spelling. And in addition to this, it can also find spell checkings using this spell check function. So it gives you a approximated number of words that can be modified to this given word. For example, we type flexibility. So the prediction from this word can be either one of this sentence. It can be the word sensibility, flexibility, or visibility, and there is a chance of whether this word is highly recommended. So in this case, the word sensibility is highly recommended because it has the score of 0.9 here. It is very high. And we can also do the lemmatizations. So the process in lemmatization is to find the base form of a given word. For example, we have the word octopi here, or we have the verb went. So the base form of these words can be found using the lemmatize functions. So there are 2 forms. Either we pass a paraspeech to this parameter, or we can just leave it empty. By default, it will use the noun paraspeech. So in case we want to find verb, okay, we can pass the parameter here, which is v, stand for verb. So as the result from this simple code, we obtain the base form of these 3 given words. And next, we can also find the language detection in a given text, or we can also translate text to some of the different destination language. So first of all, we need to create the text loop objects, as we have seen earlier. And next we can call to the translate function in order that we can translate a given text in a source language to a destination language. So in here we need to specify the target language that we want to translate this text to. For example, in text in loop 1 here, it store the English words, and next we want to translate into the French. So these are the output given from the loop 1, which in the source language it says an apple a day keeps the doctor away. So when we translate these to the French language, we have this output. So remember that we need to specify a parameters which is a shortcut for a particular language. And in addition to language translations, we can also detect a language. For example, if we don't remember the short form of the language, we can first use the detect language to find the short form of this language. So the output from here, because the given text here is written in Thai language, and because it is a Unicode, so we need to specify the letter U here in front of the string. So after the output, it is return you the short form of this language, which is represented as the letter TH. So within the translate function, there are two possible parameters that we can provide. We can actually provide two language, or we can provide both from the source language to the target language. So it gives you the same result. And next we will see on the how we can perform the sentiment analysis using the text loop functions. So from text loops, we can find the SA using the sentiment function once we create an object. So in SA, there are two implementations. Whether we use the default library we call pattern analyzer, or we can use the naive Bayes analyzers to perform that sentiment analysis. So with the pattern analyzer, it will return you these objects, sentiments, and it consists of two parameters. The first one is called polarity, and the second one is subjectivity. So the rank of the number returning for each of these parameters. For example, the polarity, normally the number is from -1 to 1. -1 means it is negative. And if it is 0, that means it is expressing a neutral idea. Or it can be 1, which is very positive. The number can actually ranging from -1 to 1. And for subjectivity, it gives how subject or opinion is regarding into the text, whether it's talking about the object or really subjects of the sentence. So the number for the subjectivity is ranging from 0 to 1. And in the second implementation, which use the naive Bayes analyzers, so from this implementation, it actually returns you objects which consists of three data classification, which contains the sentiment, either it is a positive or negative, and we have a P pulse on P negative here, which represent the positive and negative value for the polarity. So this is the syntax for using the sentiment analysis. So we can create the text loop objects using this default format. It will use the pattern analyzer. And if we want to specify a second implementation, we use the naive Bayes analyzer. We can specify a second parameter, which is analyzer, to use this naive Bayes. So next we will take a look on this example. You can create a text loops module, and from the text loop sentiments, you include the naive Bayes analyzers. And next, you create an text loop objects, which use the second implementation on top of naive Bayes analyzer. So to find the sentiments data, you can use this function loop.sentiment. So this is the result returning from this function. We obtain the classification. Okay, this word, this sentence. I love this library. So it gives you a positive information, and in polarity positive and polarity negative, it also gives you the value whether this sentence is really high positive or how negative it is. So in this case, it is around 0.8 positive number. And next, we can also find the sentiment on a piece of text. So from a previous example, we find the sentiment analysis from a given sentence. So in actual implementation, there can be many possible group of sentences that we can pass to this text loop object. So to do this, we can create a text loop object. So this one, we will use the default implementation pattern analyzer, and it consists of 4 sentences. And next, we can find the sentiment that can be found using the sentiment functions representing for these sentences in the text loop object. So if we print the sentiment here, it will give you the overall information for this piece of sentences. So we have the polarity, which is 0.73. It is a positive number, so it is saying many chance of the positive information. And subjectivity, talking about the subject in the sentence, which is higher. And for each sentence that are appearing in this input text, we can also find its sentiments. So to do this, we can loop to each of the sentence in the text loop objects. And next, you can display its sentiments. So from these codes, we can find each sentiment for each sentence. So these are the outputs for our program. As you can see from the last sentence, which says, I go to school. So this basically just describes some information. It's not positive or negative opinion of a user. So we obtain the polarity here is 0. And for this negative sentence, I had the service. So we obtain the polarity number, which is a negative number minus 0.8. So when we use the second implementation in the sentiment analysis, which is called naive Bayes analyzer, we can perform this also on the many sentences that we pass to the text loop object. But remember that we need to pass the second parameter, which is the naive Bayes analyzer. And we can also do it the same comparing to the default implementation. But as we can see here, the difference is the output, which from this second implementation, naive Bayes analyzer, we obtain 3 different information. We have classifications, whether it is a positive or negative, and it has the polarity, negative and positive number. So when we want to train a naive Bayes classifier in the second implementation for performing the sentiment analysis, we can also give some training data. For example, we set a fixed variable for storing the train sentences, as we have stored in this variable train. And next, we can use this input data to classify whether it represents the positive or negative information. So we can import this classifier, and next we can create an object in the naive Bayes classifier, and then we can train this using the data providing from the training. And to test this classifier, we have another 2 sentences. And next, you can classify the input here based on our model using the classify function. So as the result, as you can see in this output, we have positive and negative, which referring to these input sentences. So basically, the word I do not like this movie, it is talking about the negative information. And this show you more example on how we can perform the post-touching, noun phrase extractions, sentiment analysis, as well as the language translation in text loop module. Suppose that you have this piece of text which consists of many sentences. And what you need to do is you create an object first, and next you can specify a particular function or properties so that you can find a given task. Just a notice here, in case that you want to translate a function, you want to use the translations features, so you need to specify a destination language in case that you provide a wrong short name. For example, if you want to translate to Khmer language, if you type KA here, it will produce you an error because there is no short word for the Khmer language like KA here. What we need to do is to make it to the correct form, which is shorted as the word KM for Khmer language. And for each of the feature that we perform in here, we can see the output for each of these in the right hand side here. For example, if you want to find the noun phrase from this given input text, this is the output for this noun phrase. It can be an LTK, Python, human language data, and so on and so forth. Okay, now we come to the end of this module, and there are some homework for you. In the first exercise, you are asked to write a Python program using text loop module to perform the sentiment analysis on a piece of text. So the text here, basically you can find it somewhere describing about positive or negative information. And then you can insert it into a particular text file. Next, to run the program, you will need some codes to read those data from the file. In the second exercise here, you do some language translation where user need to input a source of language. For example, you want to translate text from which language to which language. Also the destination language, it can be in this list of language: English, French, Thai, Chinese, and Korean. And in the third example, it is to perform the noun phrase extraction from the input text. So next, once you translate, when you extract those information, you are required to translate each of the extracted noun phrase into a user specified language. So the process in here, user provide a piece of text, and he also need to provide a language to translate some extracted information from the input text, and you need to write those information to this text data format. Okay, thank you for joining the lecture today. We hope to see you in the next lecture.